It has been 3 months since Intel launched Arrow Lake or Core Ultra 200S, specifically Core Ultra 9, Core Ultra 7 and Core Ultra 5. And that means it's been 3 months since KitGuru ran a video saying that we did not consider these processors and the Z890 platform was ready for review because the launch was absolutely horrendous. All manner of issues which I covered in a video at that point. However, Intel has been busy behind the scenes and has made a number of changes. Drivers, Windows, firmware, all sorts. And now they claim Arrow Lake is ready for action. And this means that we can use these wonderful motherboards and the latest DDR5 CUDIMM's memory. So we can put these processors head to head with AMD's absolutely astonishing Ryzen 7 9800X 3D. But that begs the question, what exactly has Intel been doing behind the scenes? And most importantly, has it worked? A month after the rocky launch of Arrow Lake, Robert Hallock of Intel, formerly of AMD, appeared on Hot Hardware to acknowledge the problems that Intel was facing, and he was basically saying they were working very hard and would return to give an update. A month after that, so a month ago, he appeared on Hot Hardware for a second time and told us what was going on with updates for the platform.
Part of this process and part of the natural evolution of releasing a platform is that you're constantly trying to develop new performance enhancements for the platform through BIOS updates or through driver updates. And we have a couple that we're ready to check in to the BIOSes that we extend to OEMs before, and then they turn that into the BIOSes that get flashed to your motherboard. So that does require microcode 114. I understand that those BIOSes are already available on some motherboards in beta, but the missing piece is this Intel CSME firmware kit. That's like the special extra sauce that's required on top of 114 that provides this additional benefit. So that will start to flush out to users in January. Everybody is, of course, curious about the cumulative effect of all of these updates. At CES, which is, I don't know, 3 weeks away at this point, we're going to come back to the table with like a full performance sweep on nearly 40 games. We're also going to look at the final impact of each one of these issues individually. If your system was affected by it, what was the final cost with before and after of launch versus this final recipe.
So you can understand that I headed off to CES in Las Vegas fully expecting to get an update from Intel about the final fixes for Z890 and Arrow Lake, and yet apparently no such thing happened, or so I thought. Everybody's attention was on Jensen Huang of Nvidia as he announced the 50 series graphics cards that are coming any day soon and will be coming through the month of February and probably into March as well. And some of our attention was on AMD as they announced Ryzen 9 9950X 3D, and for some peculiar reason failed to announce the RDNA 4 graphics cards that we've been briefed on before CES. It turns out Intel did indeed give an update at CES, but it was tacked on the end of a briefing about other products, such as mobile Arrow Lake. And once again this briefing was given by Robert Hallock, and here's what he had to say.
I do have another closing remark I want to make. We've also been working on some performance updates on those desktop CPUs. It's at this point in time when my friends in the tech media, I saw some of you this morning, would remind me that we and I promised a final word on some BIOS updates coming for Arrow Lake S. And we're ready to share that update with you today. We'll start with Intel Application Performance Optimization, what we call APO. APO is designed to make games faster by helping them make better scheduling decisions. Not all games understand intuitively every single CPU and how they're built. So sometimes a little bit of software help can improve the performance of these games. Getting APO up and running can convey up to 14% additional performance in PC games, And this update, this capability, is subsequent to the hardware reviews that are in market today. So 14% upside in games, and then 5-7% in some cases. It's a serious performance boost. Now, getting APO up and running only requires Windows Update. And if you live and breathe Windows updates like I do, that's Windows build 26100.2161. That came out in November. So if you have that, you have APO. The next major performance benefit lies in what power plan is toggled inside of the operating system. All right, when you install Windows Fresh, balanced power plan is the default. It is the standard out-of-box solution for the Windows power plan. Like the name implies, it tries to balance power consumption versus performance, but gaming PCs are all about maximum performance. Now, we originally intended that users could toggle between these plans, but in practice, we found that most users basically just stick with balance plan by default. They don't change it. Now, with the latest updates, we've made that out-of-box balance plan the fastest plan by default. Everyone just gets the fastest, best performance by default, no toggling. Performance gains for doing this can be pretty generous, but lightly threaded workloads like Adobe Photoshop are very sensitive to small changes in parameters controlled by these power plans. So there is disproportionate upside for this change that we've made in software like Adobe Photoshop, not just games. Most significantly, hardware vendors like Intel can alter the behavior of the Windows power plan with a software called a Performance and Power Management Package, also known as a PPM. A PPM controls CPU frequency ramp from low to high to low, what cores are awake or asleep, how long they sustain their maximum frequency, and so on. Many dynamic voltage and frequency scaling parameters are controlled and influenced by this PPM. These parameters can have knock-on benefits to single-thread performance, memory latency, and energy efficiency, all metrics that matter in gaming especially, but any other workload. And the PPM package is most beneficial to systems running that balanced power plan, which again is the Windows default. Any application that is sensitive to memory access or the performance of a small number of CPU threads will get a pretty generous kick from having this PPM in the system. And the PPM has been available for a little while, again, in that build 2161. So that was a key update automatically applied in November. Last but not least, we saw certain motherboards that had some BIOS settings that didn't always convey the best performance, and that was on us. For some systems, a feature called AutoGV was inadvertently left enabled, and that was our mistake. CCF AutoGV controls the frequency at which one CPU core can talk to another. And on Arrow Lake S, that should be 3,800 megahertz from one core to the next. Not the frequency of the CPU cores themselves, but how quickly they can talk. With this feature left on, sometimes that frequency would go as low as 800 megahertz in an effort to save power. That power saving makes a lot of sense for a mobile solution where you might spend most of your time at the desktop, but it doesn't make a lot of sense for a gaming CPU. So we worked with our partners, and a huge thank you to our motherboard partners for implementing this change. And BIOSes from December onwards have this setting toggled correctly. And certain workloads, like file compression, heavy mathematical, synthetic workloads, those see a pretty healthy uplift. 4% is actually pretty big in a market like this with a workload like this. So if we put it all together, let's add it all up. If you compared a system, an Intel Core Ultra 200S from October to today, what could it look like? Games could get as much as 20% faster. Lightly thread applications could get as much as 50% faster. And heavy GPU utilizing workloads could be nearly twice as fast. Memory latency also falls as well on some systems, and that's good for gaming performance too. But I also want to be realistic with you. The exact benefit you experience on your system from these updates, it depends on your build, your software updates, when you tested, what BIOS you have, what graphics card you have, what version of Windows are you running, what game are you running. There's a million variables here, and there will absolutely be a wide range of results. And all of these software updates are available today. If I could leave you with any one thing, it's this. Our software for the 200S has reached full performance, and our final BIOS updates are reaching the web as we speak. Arrow Lake S is ready to rock. The 200S desktop CPUs are ready to rock in time for all the new SKUs and chipsets I've announced today. And I want to say I deeply and earnestly appreciate the feedback from the tech reviewer community and the user community.
Before I tell you what I found when I retested Arrow Lake and also Raptor Lake and AMD Zen 5, let's just cover a couple of points that Hallock glossed over in that presentation. For one thing, we have seen a whole bunch of updates that came out very soon after Arrow Lake launched, which essentially allowed us to run Arrow Lake like a normal platform. For example, updates that allowed your motherboards to boot with a retail processor rather than an engineering sample. Also, updates that allowed you to install Windows without dancing around using the integrated graphics before you switched over to a PCI Express graphics card. And then there's the business with the Windows 11 power plan. As far as I'm aware, every single reviewer used the high performance power plan, and that's because the balanced power plan essentially did not function. It's my thesis. I may have said this in a previous video. I've truly lost track. We've covered this topic so many times now. I think Arrow Lake was developed as a mobile processor, and when it was launched as the Core Ultra 200S in desktop form, someone somewhere more or less forgot to switch on certain features to allow it to function correctly as a desktop processor. That, or they totally forgot to check that Windows 11 was treating it as a desktop processor. Sounds like an absolutely fundamental mistake, but that's how it seems. So both power plans in Windows 11 now function identically as far as I can work out. You'll notice that in the presentation there, Hallock said the balanced power plan is the best power plan. I went back to him to check this point. I think it's probably more correct to say both power plans work the same as each other. However, I retested using high performance just as I had in the first instance. I then switched over to balanced power plan to check there was no nasties going on, and we're good. When we look at one of the other slides that Hallock showed us on screen, we see a couple of slightly peculiar claims. Now you can understand that Far Cry 6, for example, might have jumped 16% in performance, but 3D Mark TimeSpy jumping by 97% on the face of it is utterly ridiculous. What has actually happened here, in my opinion, is that when I ran 3D Mark TimeSpy on the balanced power plan, it basically didn't work. It crashed by 50%. So when I initially ran it on the performance power plan, it ran correctly. Now I can also run it on the balanced power plan. So it jumps from 50% of where it should have been to where it should have been. So yes, that's plus 97%, but that's because we're starting from a point of 50% and we've returned to normal. Also, memory latency. The latency in Core Ultra 200S is very slow, and that's because the memory controller is in the I/O tile rather than the compute tile. It is inevitably going to be slower than we'd like to see. This means that latency for fast memory is in the 85 to 90 nanosecond bracket, which is quite slow. However, I've seen latencies at 135 nanoseconds or as bad as 180 nanoseconds when things go really wrong. In other words, and you can do the maths here, if your latency has dropped to 135 nanoseconds because of the Windows power plan, and then it reverts to 85 or 88 nanoseconds, hooray, you've just saved 30%. But again, what we're doing here is we're returning to where we should have been in the first place. And the fact is 85 to 90 nanoseconds is not great. It's just what we expect from this platform. Before I get into the charts of how I retested this hardware, let me just read you a handful of notes. So clearly Windows updates is a significant part of the equation. I originally tested using Windows 11 24H2 26100.2033. I've retested on the latest version of Windows 11 H2, that's 26100.26054. That in and of itself makes a big difference. Secondly, the original Intel microcode on this platform was 0x110. We've stepped through a number of versions. We're now on 0x114, which is the correct version. The original ME firmware was 19.0.0.1753. It is now 19.0.0.1854. This business of version 2.2, that just seems to have dropped off the radar. We are on the correct ME firmware. The NVIDIA driver for my RTX 4090 has been slightly updated. It was 565.90. It's now 566.36. Other settings I've used, resizable bar is enabled. The default of VBS or core isolation is enabled, and I have used the high performance power plan, although as mentioned I've also confirmed the balanced power plan works exactly the same. And having said all that, let's get on with my charts. Cinebench 2024 multicore is a benchmark where the various updates have made no apparent difference. What you're looking at is the chart I used 3 months ago. However, I've changed the colouring of the bars. So Core Ultra 200S is coloured in blue, AMD Zen 5 in red, Intel 14th Gen Raptor Lake in green, and yellow is other. And we see that Core Ultra 9 285K is at the top of the chart by a narrow margin from Ryzen 9 9950X. In other words, Core Ultra 200S does perform and is not complete rubbish, despite the general negativity that surrounds this platform. Moving on to Cinebench 2024 single core, here we do have some slight differences between the original figures and the retested figures, but this applies to both Intel and AMD. Ignore the old stuff at the bottom of the chart, the yellow, and focus instead on the green, the blue and the red. If we look in the upper region of the chart, we can see at the very top we have the retested Ultra 9 285K on 146 points. The original figure here on line 3 was 139. Meanwhile, the AMD Ryzen 9 9950X has had the tiniest of bumps with the updates in Windows. It's gone from 139 to 140. Similarly, Core i9 14900K started on 136 and crept up to 139. You can see this trend with all the processors, slight increases. However, the Core Ultra 9 has had the biggest bump. In Geekbench 6 multi-core, and this is a benchmark that tends to favour newer technologies, we see that Core Ultra 200S steps up very slightly. At the very top of the chart, Ultra 9 285K goes up from 22,279 to 22,750. Around 500 points. It's a similar story for Core Ultra 7 265K, up from 20,857 to 21,317. We don't see similar changes for AMD Zen 5 or for 14th Gen Raptor Lake. Whatever has changed in Windows seems to favour Core Ultra 200S and only Core Ultra 200S. In Geekbench 6 single core, it's a similar story. I saw no changes in AMD Zen 5, I saw some incredibly tiny changes in 14th Gen Raptor Lake. For example, Core i9 14900K stepped up from 3212 to 3219. Utterly trivial. Meanwhile, Core Ultra 9 285K increased from 3187 to 3323. That's a noteworthy change, but it's still eclipsed by AMD Zen 5. And it's worth noting when we look at power consumption, just the processor, not the system, and we see that 14th Gen right at the bottom of the chart, more power is worse. Core i7 and Core i9 are drawing 253 watts under load. Core Ultra 9 285K is drawing 235 watts under load. The Ryzen 9 7950X in yellow 222 watts. Core Ultra 7 265K 220 watts. And then we come to AMD Zen 5, the Ryzen 9 9950X drawing a mere 200 watts under load, which falls between the Core Ultra 7 and the Core i5 14600K. You have to go quite a long way up the chart or down the figures to the Core Ultra 5 245K on 135 watts. Intel's Core Ultra 200S does indeed draw less power than 14th Gen Raptor Lake, but it's not a lot less. AMD Zen 5 draws significantly less power. And we move on to gaming, starting with Cyberpunk 2077 on the Ultra preset running at 1080p. We're only looking here at Zen 5 Ryzen 7 9800X 3D, Ryzen 9 9950X 3D, the 3 Core Ultra 200S processors, and the 3 Raptor Lake processors. At the bottom of the chart we have 3 blue bars for Core Ultra 200S before the updates, and you can see those scores are very closely tied together. Then we have 3 green bars for 14th Gen Raptor Lake, which beat Core Ultra 200S quite comfortably. Above that we have 3 blue bars for Core Ultra 200S after all the updates, and we can see a significant leap forward both in terms of average frame rate and also 1% low. However, above the Core Ultra 9 285K, we have the Ryzen 9 9950X, beating it by a single FPS in both average and 1% low. At the top of the chart, by a very clear margin, Ryzen 7 9800X 3D. Our second game is Far Cry 6, again an Ultra preset and at 1080p. The bottom 6 bars are all blue, and it's a mix of Core Ultra 200S old and new figures. Actually, this is confusing. Let's just reorder these figures. And now we see the Core Ultra 5 jumps from 99 on average to 145. The Ultra 7 jumps from 138 to 160, and the Ultra 9 from 149 to 173. Clearly, these are very large increases. However, they're beaten by Raptor Lake. The Core i5 14600K average of 175, the Core i7 185, the Core i9 191. The Ryzen 9 9950X is in the middle of that lot at 180. The Ryzen 7 9800X 3D clear away at the top of the chart at 255. Our third game, Avatar Frontiers of Pandora on Ultra preset at 1080p, is significant because when we first reviewed Core Ultra 200S, the launcher for this game gave all sorts of problems. This game has certainly been updated, along with updates in Windows, drivers, firmware and everything else. There's a lot going on behind the scenes, and the results of these benchmarks are quite surprising to my eyes. At the bottom of the chart we have 3 green bars, which is Raptor Lake, the original figures. Above that we have 3 blue bars, Core Ultra 200S, the original figures. Then we have 3 green bars for Raptor Lake retested, 181 and 182 FPS on average. Above those figures we have 3 blue bars for Core Ultra 200S retested, 180 to 182 FPS on average, so the same. However, the 1% lows are about 5 frames per second higher for Core Ultra 200S than they are for Raptor Lake. At the top of the chart we have AMD Zen 5. If you zoom out you can see how peculiar these figures are. Originally Raptor Lake was significantly slower than Core Ultra 200S, but after all the updates the two processor families are very similar, and despite all that AMD Zen 5 takes the win. Moving on to Total War Pharaoh on Ultra preset at 1080p, the easiest thing is just to show you the before and after figures for each of these processors. You can see the updates have affected every single processor's result. However, the order of the processors doesn't change one jot. At the bottom we have Core Ultra 5, and above that we have Core i5. Then we have Core Ultra 7, and above that Core i7. Above that Core Ultra 9, and then Core i9. In other words, 14th gen Raptor Lake consistently beats Core Ultra 200S, albeit by a fairly small margin. The processor second in the chart is the Ryzen 9 9950X, and we can see the updates have had a really significant impact on performance here, jumping from 239 FPS to 257 FPS. Top of the chart it's the Ryzen 7 9800X 3D. The very strange thing here is the updates have had almost no impact. A single FPS is definitely within margin of error, but the overall score is absolutely massive. Our fifth and final game is Assassin's Creed Mirage on Ultra preset at 1080p, and here you can see the updates have had effectively no impact on Core Ultra 200S. The bottom 2 bars are Core Ultra 5 before and after the updates. A single FPS is within margin of error. Then we have Core Ultra 7, where the average remains the same. You can see that Core i5 14600K has exactly the same performance as Core Ultra 7, despite running on less power. Then we have Core Ultra 9 before and after the updates. The figures haven't changed at all. Next we have Ryzen 9 9950X. Above that we have the Core i7 and Core i9. And top of the chart by a wide margin, as expected, Ryzen 7 9800X 3D. I imagine those benchmark results have caused a certain amount of what the hecking, and I don't quite understand what I'm looking at here. And I can understand that puzzlement. That is certainly how I feel. It's obvious that Intel has been working very hard behind the scenes. It's crystal clear that things have changed, but thankfully we do not have to reach a conclusion today. The good news is that Core Ultra 200S is indeed ready for action, and therefore I can start working on reviews of these 3 processors and the Z890 platform. and you can expect to see those videos in the very near future. Don't forget, we're on TikTok and it's kitguru.net on the web.